All right, everybody, we'd like to welcome you to the webinar today on gas distribution systems. This is webinar number 2 in our 2021 series. Thanks a lot for joining us. My name is Chris Kiesling. I'm the operations manager here for the Michigan-Toledo region for Swagelok. So a few housekeeping things if you've never been with us before. First and foremost, you'll notice your cameras and microphones are turned off. If you have a question, please use the chat feature. If that's not working for you, you can email your questions to solutions.michigan@swagelok.com. When you ask a question in the Q&A function, please include your name so we know who we're talking to and we can address you directly. Also, we can follow up in case there's anything else you need on your topic from the question. So if you have any questions after the webinar, you can contact your Swagelok account manager or reach out to us through that same solutions.michigan@swagelok.com. I love doing these webinars, so I want to thank you very much for attending today. So with all that out of the way, I would like to welcome Michael McCauley as our presenter. Michael is a mechanical engineer from Michigan State University who joined our team a little over a year ago, almost 2 years now, as a sales engineer. Michael handles a lot of our industrial gas customers, so he's a perfect guy to talk about gas distribution systems. Michael, go ahead and take it away.
Thanks, Chris. So we're going to get this webinar started, and similarly to how we've done it in the past with the what, when, and why of gas distribution systems. So the what is to develop and install a system that provides the correct pressure and flow from one or more sources to various users. The when, we want to do this during the design and planning phase to make the installation of your project easier. And the why, we want to create a system that's easier to operate, easier to maintain, and it's safe to do that as well. Some of the other stuff we're going to cover in this webinar are the different elements that go into a distribution system, some of the tips to make sure you're selecting the right materials and layouts of your project. And we're going to teach you how to diagnose some of the common issues we find out in the field. So what is a gas distribution system? In simplest terms, it supplies gases from a source or group of sources to different end users. It provides control of both your pressure and your flow, as well as isolation to meet the needs of your end users. And we're going to walk through an example right here on the right. So here is our source, a cylinder of 3,600 PSI, we'll say nitrogen. And just as an aside, this presentation is going to mostly cover bottle and liquid tank supplies, but a lot of what we discuss also applies for process gases and other systems. So out of our cylinder, we're going to go into our initial pressure control. I'm going to use that regulator there to drop the 3,600 PSI down to 200. Out of the regulator, you see we have a flow meter here as well to control our flow. Coming off of our flow meter regulator combo here, the top line is going to go out with controlled flow from the flow meter, and the bottom line is going to continue on its way at that 200 PSI as well. And then from that line, it's going to break off again. You're going to see it split down into that second regulator, which is going to drop the flow further from 200 to 45 PSI. And then the branch off that T is going to continue on at 200 PSI. So the goal here is to be able to do all this pressure and flow control safely as well. So we're going to start our system at the start with our source element that are going to be kind of right near your gas source as we go through. You can see two types here. The first on the left is that gas control panel with that regulator setup. And the one on the right is a cylinder bank control with all those cylinders set up in parallel. So the primary goal of here with your initial pressure reduction is to reduce the pressure initially and get that transport pressure down so that if you end up having springing a leak somewhere down in your system, you're not losing as much of your gas. This can be a trade-off though, as you're likely going to have to increase the size of the line that's transporting that gas. So focusing on our cylinder setup here, some things you would want to consider when running this type of source element. You want to make sure that your cylinders are able to be stored properly and held upright, and so you're not going to knock them over by accident. And you also want to consider some sort of cap storage. If you don't want your cylinder caps rolling around on the ground or losing them when you need to deconnect them from the system. And the goal here as well is to provide a lot of consistent layouts and make sure that your system is reliable and runs smoothly. Moving on from our source elements, we move into a possible source or point of filtration. So filters are important for a variety of reasons in your system. So they're useful for helping protect your downstream components. You can see this example here of a inline filter. And you can see that you can actually set this up in a vertical or horizontal orientation. And like I said, the primary goal here is to protect your downstream components. So if you have, say, an old cylinder that's having tiny bits of metal flake off, or if you somehow get a foreign particle inside your system, filters are really helpful, making sure that your downstream valves and regulators aren't affected by that. So looking at an example here of why filters are important, this is actually a ball valve, the seat of a ball valve that we did an investigation on for a customer that was having some trouble with leaking. And as you can see here in those circled red dots, these little flecks of black here are bits of metal that got embedded in that seat of the ball valve. So over time, as the ball down here was actuated, it ended up scoring and wearing lines into the ball valve so that it got to the point where even when it was closed, it was letting fluid pass, something that could have potentially been avoided if we had an inline filter. And then there's some downsides as well to using a filter. They are a maintenance item. You're going to have to swap out the filter element periodically to make sure that you're not having any issues with plugging, so that your system can continue to flow and work properly. You want to make sure you're considering your selection with your filter. That inline filter there needs to have its connection broken to be removed and have that element replaced. So maybe a T-shaped filter that doesn't require that might be the better option. And another thing to consider as well is entrapment, which can be an issue in high purity systems. So if that becomes an issue, I'd recommend reaching out and we can take a look and see what we can do. Flowing through our system to the endpoint right before our end user, we have our point of use stations. This is going to be our last source of pressure and flow control right before we get into our end user, either an analyzer or some such. And you want to make sure you're picking out the right valves and regulators for that. So in terms of your flow control, looking at valves initially, you want to make sure your CV of your valve is properly sized. So your CV is your flow coefficient. And that's going to be dependent on the flow rate in your system as well as your media as well. So it's important to consider what requirements your system has. And if you need help calculating that, Swagelok.com's got a really nice, easy to use calculator, so I recommend just checking that out on the webpage. And then looking at regulators. So when you look at regulators and they talk about the CV, that actually corresponds to this choked flow region here in the blue. Oh, I'm sorry. This choked flow region here in the blue. And the ideal range for your regulator to be sized is this droop range here, because it's going to give you the best variability for your system and able to compensate for any source of changes in your system's flow and pressure. And if you're interested in taking a deeper dive into regulator and valve selection, we have a webinar from a couple months back that I recommend you check out on our website. And then there's some special features we want to consider as well. Maybe you need a flow meter to have that more fine-tuned control on your flow. Maybe you need a specific isolation valve when you're making sure that right before your system, so you can disconnect if necessary. Or if your system's on a more critical, you have specific requirements for your flow or pressure. Maybe you have a pressure alarm tied to your system so that if anything changes, you can be notified. So getting into our, before we go any further, I do want to bring up some of the safety considerations that go with using an oxygen system, because oxygen can be a pretty significant safety hazard if set up incorrectly. So just to review the fire triangle here, you have three points here. So you need, to create a fire, you need oxygen, you need fuel, and then you need a heat or a spark to start the reaction. So there's a couple ways you want to go about avoiding an oxygen fire or any sort of safety hazards there. So the first I would recommend is making sure your system's cleaned and the components are all cleaned for oxygen service. The Swagelok SC11 is a good way to make sure your components are working properly for that. Oils and greases can get built up in a system, be it valve lubricant or some such thing, and making sure that those are avoided or cleaned out, again, with the SC11 as an option, or is important. You also want to consider your tubing as well. You want to make sure your tubing's inner diameter is smooth bore, because even that microscopic roughness that comes with the stainless steel there, or the whatever your tubing material is, can create potential points where particles can strike and create sparks. And another good way to avoid that would be to prevent any sort of improper connections to oxygen. Making sure your lines are properly tagged. I've seen an example of a customer who switched all their oxygen lines over to left-handed threads because someone hooked a grease gun up to one before, and the result was not good. So getting into some of the materials and selection as well, making sure that you're using the proper materials in the metals. You don't want to use anything that's stainless steel that gets above 150 psi, because stainless steel can spark off of any sort of collisions, be it particles making bends in your system or any sort of small pieces that break off components. And you can see this here down in these photos with that T. That inlet was the run of the T, and it looks like instead of branching off to the left or right, it kind of just kept going and blew out there, as well as that valve example up top. So you're not supposed to use stainless. What do you use? We recommend using brass or alloy 400 because they don't spark or burn in the same way that stainless steel does. You also want to consider your soft goods, any sort of elastomers or O-rings, making sure that they're suitable for oxygen service. And you can see here an example of a changeover regulator. All of the connections are done in brass, and all the tubing is done in copper, so suitable for oxygen. And then the last consideration as well is slow opening valves. They reduce the heat that comes from that instant open and close with a ball valve. Maybe use a needle valve instead. But just a last note that these systems can get kind of dangerous. So please, if you have any questions or concerns, feel free to reach out. We want to make sure everything's done safely. So getting into some of the other special considerations in your gas system, this right here is a changeover regulator, and it's helpful for providing that uninterrupted flow when you have a more longer running type of process. So how this works is you'd hook up your two cylinders to the system here, and you'd set whatever your desired changeover pressure is. We'll say 200 psi, for example. And once your first tank reaches that 200 psi, it'll change over to the other cylinder, and you won't lose any of that pressure downstream. So why is this important? It's important to protect any sort of downstream components that have a minimum requirement for pressure. So you've got an analyzer or something that absolutely has to have that 200 psi, and if you're changing cylinders, once it runs completely out, can be problematic. And you might have a high batch cost for the product that you're running, and swapping out a cylinder could cause a defect, or you could lose time in production. Or maybe you've got a long time running analyzer that if you swap over cylinders, you're maybe corrupting your results, or making sure your conditions will end up non-ideal. And of course, this can also manually swap over as well if you get to that point. So maintaining your system is important to making sure your system's working properly. And one of the most important ways to do that is checking for leaks. Once you've pressurized your system, it's always a good idea to go around and snoop your lines or put some liquid leak detector on your connections to make sure you're not having leaks. And I mean, it's helpful because you're not losing any of your gas, and it costs money. Gas isn't super cheap, so you want to make sure you're not losing money with that. This is actually a video here of Chris snooping a valve, and you can see those bubbles there that show that he's probably got something wrong with his system somewhere. And if you're interested in a more deep dive on leak detection and different methods, our webinar last month actually covered that, so I'd recommend checking that out. Next, we want to take a look at some of our hoses and flexible tubing, making sure you're checking for any sort of cracks or kinks, any sort of bad routing that might potentially cause those cracks or kinks. You can see here on the left, this orange hose is actually a result of UV attack, ended up causing those cracks there, which is letting gas flow through. You can see in the bottom there, making sure that your bend radius isn't too tight. You'll end up putting unnecessary strain on the end connections, which can end up causing a leak. And making sure you're avoiding kinks is useful as well. You can see the plastic tubing there. Not good for making sure your flow stays where it needs to be. And then finally, we want to make sure we're checking out our isolated and unused lines. Hopefully nobody's working with a process that's quite this complicated, but say you were, how would you even be able to tell what's in service or what's not, what's pressurized, what isn't? And it only gets harder as the system gets older and maintenance needs to inevitably be done. So it's always good practice to make sure if you have any dead legs that you're either capping them off or removing them from the system altogether. So getting into some field diagnostics. First, we want to talk about some hose considerations. So if you've seen the picture here, you want to make sure you're eliminating end strain on your hoses, making sure that all the weight from your hose isn't being put on that initial end connection. And a great way to do that, especially coming out of a cylinder or a regulator, is to put that elbow there. It makes that bend a lot smoother, and so you're not straining your hose. And that's one of the most common things we see out in the field with hoses off of cylinders and regulators. Then I want to talk about a little bit about the supply pressure effect. This happens as your tank is being depleted. So as it turns out, as your cylinder pressure decreases, the outlet pressure out of your regulator increases. And this happens because of the balance of forces that occur within a regulator and all the work that goes into maintaining that pressure. So we're going to use an example here to calculate that. So you start with your 3000 psi, that's the cylinder pressure. Your regulator CV is that 0.2. And the control pressure you want to get out of your regulator is 90 psi. So you're going to take a look at your 0.2, come down to here, go across, and that's going to result to a 1.7 supply pressure effect increase, which would result in a 115 psi as of the outlet pressure from your regulator. And it's important to consider, can your system withstand that? If you have a pressure requirement downstream that is expecting 90 psi and can't handle that 25 psi increase, then it's something important to consider. So how do we avoid the supply pressure effect? There's a couple ways. The first is to use a two-stage regulator, which does two separate pressure reductions all within a single regulator, and it's helpful in avoiding that, as well as using multiple regulators throughout your system. Maybe you have one right off of your cylinder, and it goes through a transport line and gets down to your point of use, and you have another regulator right there. Both helpful ways to making sure this isn't a problem. So how can we help? Swagelok makes a series of modular standardized systems that can be further customized to better suit any specific needs. You see two examples here. So you have your lab example and then your analyzer shed example. And you can see here with this lab example, you have the cylinder connections here, your primary gas control panel here, and all this goes out to these group of analyzers with each having their own point of use final pressure reduction. And then you can see over here as well this automatic changeover for the more critical processes that can't be interrupted. And those same products can be effective in a different situation with this analyzer example here. You have your primary gas control once again, your cylinder bank setup, and then your automatic changeover. No point of use regulators because you're going into the system and everything's at the same pressure, so you don't need that final level of pressure reduction. And this is just some examples of ways we can come out and take a look at the system and help advise. So you start off with your source element with being these cylinders here. You go into your initial gas control with the regulator panel here, your final point of use regulator, and then getting into any sort of special considerations like this changeover panel here. And these can be further customizable, like I mentioned. You can have other company logos put on them if that's a requirement, maybe instructions for the end user or operator to make sure that it's easy to use, as well as a spare parts list, say something you need to swap out a fitting or a valve specifically, and you need to make a repair and you need to know what you're swapping out. You can do that as well. And any sort of further customization rather can be discussed as well. And if you have any more questions as well on the specific valves and regulators that go into these panels, we do have our valve and regulator selection webinar to take a look at as well. So to go back to our initial what, when, and why to review, our what was to develop and install a system that provides the correct pressure and flow from a source to various users. The when, you want to do this during your design and planning and making sure that your installation is as worry-free as possible. And then the why, you were trying to make a system that's easy to operate, easy to maintain, and you can do all that safely while you're operating and maintaining your system. And if you have any questions or concerns on any of these topics, please reach out. We'd love to talk about your application. With that, I am going to turn it over to Chris. I think we have some time for some questions.
Yeah, hey, thanks, Michael. Appreciate it. We do have some time for some questions. We've got a bunch of questions in here. If you have one, please get it in because we will try to do our best to get to all these today. So start off, this is a good one for you, Michael, is in the slides you talked about entrapment. I think when you were talking about the filters, what does that mean? Jim F. wants to know, what do you mean by that, and how does he know if he's got entrapment? What should he look for?
Oh, that's a good question. So entrapment is when you actually you've got a mix of different gases, and in one of the components, it builds up in part of the system. So usually you see it with when you get an ultra high purity system, when you're doing kind of a more sensitive analysis. Even if your gas is 99.99% pure, you get that 0.01% other stuff, be it other gases or other particles, and that can build up over time. It tends to happen in areas where dead flow occurs, or if you have like a tight geometry, maybe a sharp bend. And if you're noticing something, kind of an anomaly, or you're kind of concerned, feel free to give us a call, and we can actually come out and take a look at it with our engineering team.
All right, great. Thanks, Michael. Next one we had that came through here, Kyle E. asked, I think this is back when we were talking about regulators, when we were showing our diagram, is why do we use CV, or why is the CV calculated at the choke flow region? Kyle must have called into one of our previous webinars where we talked about how we should avoid that and not be in the choke flow region when we select a regulator. So he wants to know why is CV calculated there?
Oh, that's a good question. So CV actually is really more about the flow capacity of a component, like a valve or a regulator. And the point where you get that choked flow in a regulator happens when the flow is at its highest. But it's the reason we avoid that is because when it's fully open and it's giving you that full flow capacity, it's not really regulating pressure. It's pretty much just an open vent for your system to flow fluid through. So it's usually you want to stick in that drooped region because that's going to give you your actual pressure control with your regulator.
Okay, great. Okay, so we got a couple questions here from Russ. I think I can answer these hopefully myself here, Michael. I'll see if you've got any other things you want to add to it. So Russ asked me, what's the difference between SC11 and CGA standards for oxygen cleaning is the first question. So on that one, SC11 is a Swagelok standard that we clean to. It's considerate, and it was based off the CGA standards along with a couple of other sort of industry best practices. So if you're ordering from Swagelok, we refer to that as SC11. Again, CGA standard is perfectly good for cleaning for oxygen systems. Ultimately, you want to go out to some kind of a standard and look for that oxygen clean component, or look for that cleaning on any components you use if you are doing an oxygen system. It's a good point that Russ, CGA is a perfectly good standard to go to make sure you hit that oxygen cleaning. And I do not remember the standard number off the top of my head for CGA. Russ also asked, are the use of check valves required or recommended on multi-cylinder manifolds? In this case, I think it depends on how you set things up. If you have, say you've got 3 or 2, I think 2 is the easiest, right? You've got 2 cylinders of the same gas banked together, that you're just using a valve or something to switch between the 2 of them. You don't necessarily have to have a check valve to prevent cross flow back into it if the valve leaks backwards. I mean, ultimately, all it's going to do is backfill one of the 2 cylinders, so it's not necessarily required. It's nice to have it because that's what's going to be preventing in that case is getting your full cylinder leaking back into your empty cylinder, so they're just depleting at the same time. Then basically defeats the purpose of having 2. But as long as you have an isolation valve there, having some sort of isolation between the 2 where you can take one off at a time and change one off at a time is more the important part of it. Making sure you have a good quality isolation valve that you're going to be able to maintain isolation as well, since that's the purpose of it. If you're looking at situations where check valves most certainly recommended, or where I would see the requirement for check valves, if you're doing any sort of gas mixing, because you don't want to contaminate one gas with another. So upstream of, say, a T where you're mixing 2 gases together, or a couple of needle valves or something, you definitely want to have a check valve to keep from having different types of gases contaminate each other. Michael, anything else on either of those, the SC11 standards, or any sort of thoughts on check valves for multi-cylinder setups on manifolds?
No, I think you pretty much covered it, Chris.
Okay. All right, then we are going to move on to the next question here. So our next question is, let me go back to the next one here. So how do you deal with supply pressure affected changeover regulators? You showed changeover setup. This is from Rich. He was asking if he's got a changeover, how do you deal with that supply pressure effect?
So with the changeover system, actually I know ours use a two-stage regulator, which tend to be already a little bit better about dealing with that supply pressure effect. And if you do still have issues, say the pressure drop you need is pretty significant, you can always integrate a second regulator further downstream, maybe at your end user, to help further reduce that effect. It is kind of how you design and lay out your system. So if you got any questions on that, we can definitely help out with.
Okay, great. So we have another question here that just came in. So what regulator are you using in your standard gas panels here? What is its CV and uniqueness compared to other models like KPR and KCM series? So I can answer that one. Is the panel itself, we select the regulator based on the application. So on those, we will use actually a KPR, maybe a KCM, maybe a KCY, depending on what the actual application is. So ultimately, those panels, those distribution panels that we showed there, they're a standardized design, and then we drop in the components based on what the needs of the system are. So, for example, you asked if there's any uniqueness or anything special with the CV. The CV in that case is going to be selected based on what the flow demand is of your system and based on what that regulator curve looks like. Similarly, I think Michael had a couple shots where he showed. In fact, the changeover regulator he showed had the changeover regulators and it had a secondary regulator on it. That's a nice feature to have for like he just mentioned, for reducing supply pressure effects. So generally speaking, we're using the same base components. It's just how we configure them, how we put them all together to make these kind of standard builds. So, oh boy, we've got a ton of questions here. So I'm going to keep plowing through as many as possible. What type of hose should I use for the cylinders? Michael, you want to answer that one? Is what type of hose should we be looking at if we want to hook directly to a gas cylinder?
Yeah. So I hate to say that depends, but it kind of does. It depends on your cylinder pressure and what you're running and what diameter you would need for your hose. For most gases, we typically use all metal hoses. They tend to be the best for pressure containment. And some gases aren't compatible with metal hoses. Say you're running an oxygen system. But if you need help selecting a specific hose, your best bet's to call us, and we can help walk through and make sure you get the right hose for your application.
All right, I think we got time for one more here. So Bill L wrote, "I'm building a big lab. Is there a limit on how long gas lines I can run, or how many branches?" So I guess he's putting together a bigger system, and he wants to know on overall size, is he limited at all? Is there any sort of limitations he should watch out for?
Limitations. So I think with that kind of project, you're probably going to have to worry about the pressure drop across your system is the first thing that comes to mind. You need to know how much each of your I guess gas users are going to need at their peak, and then you have to make sure you're sizing your lines and making sure you're picking your regulators accordingly. So if you have a lot of different branch offs or bunch of different places that gas needs to go, you need to make sure your transport pressure is as high as possible, so your system can you have enough pressure once you get farther out that it's not going to be a problem. And also another thing you want to think about too is how often you're changing out your cylinders, especially if that's where your main supply is going to be coming from.
Yeah, that's a good point. Those bigger systems, I think a lot of times we see people doing more like a bulk liquid system from their gas supplier, because you're obviously going to be chewing through a lot of it if you're connecting a lot of users, right? Okay, well, great. I think that's it for time and questions. So last minute here, we're just going to go over a few closing items. So again, I'd like to thank everybody for joining us today. As being part of this presentation, you're going to receive an email follow-up afterwards. It's going to have some great reference materials in it, some case studies and a little Q&A session. And some general information. We'll also have a link for the video for this, so you can watch the webinar back or share it with your colleagues. Please share it out to anybody who's interested. If you are interested in having us come out and take a look at your system or help provide some support, like Michael touched on in the presentation, you can schedule a virtual meeting with us, or we're getting to a point now in Michigan where we can come out and see it too. So for a virtual meeting, go to michigan.swagelok.com or reach out to your account representative. We would love to have you guys join us again for our next webinar. Upcoming webinar is going to be on directional flow. So we're going to be covering check valves, needle valve flow direction, a little bit on regulators, just directional flow in general. It's going to be March 18th, 2021 at 10 a.m. And finally, if you have any sort of questions at all, you can reach out to us via our website or via the email address there at solutions.michigan@swagelok.com. Love to get any feedback from you guys on these webinars. We like doing them, and we like getting customer feedback and providing you with the content you're looking for. Thank you very much for joining us today. For more information about the webinars, please visit the website. Thanks, guys.